call this, this method on a socket, and it would be an async method in the operating system and return all the way back up to your code straight away and continue running. And then somewhere deep in the .NET runtime, it would poll this socket, see if there's new data, and at some point in the future, it would schedule this job to come back and call back into your method again, back down in this other part. And there really was no thread. And I was pretty amazed. And then I got to many years past, and I'm at Easy Agile, I was working in JavaScript, and I've just taken this to heart, this idea of async await, there's no thread, and Rob's going, there must be a thread jarring up there, blocking somewhere. I'm like, Rob, there's no thread. I've just been parroting this thing, but I actually have no idea how Node works. This is just my .NET background, so I thought it'd be a good idea for a Siligong talk because no one volunteered to do a talk. I had to do one. So I thought I'll try and work out how Node works. It'll be interesting to do a talk about that. And why does it matter? Because I hate threads so much. I spent so much time like in the .NET world dealing with threads. And like I was doing these desktop apps in Windows Forms. Like you click a button and you have to read a file and make a network request. And so that you didn't block the UI and it all frees up, you had to spin up a thread. And the thread would do the request, and you had to work out how to get the data back to the main thread to update the UI, and you have locks and message passing and all this stuff. And it's all just useless because you're not doing two things at once. You're just doing one thing, and then you're spinning up a thread to wait for the operating system. And the operating system has APIs to do stuff async. So it was all stupid. And I came to JavaScript land, and there is one thread. And do you know how many times I've used a web worker? 0. Because unless, like, maybe you need threads, you're making a web server or something, but in day-to-day application code, you don't need threads. And this is something a mentor of mine said back when I was a long time ago. It's like, Jared, there's developers who understand threads, and then there's developers who think they understand threads. And I thought I understood threads, and I really don't understand threads. And then back when I was doing .NET, I'm doing like thread-free data structures and spin locks and memory barriers and all this stuff to like do thread-free programming, and it's all stupid. So anyway, back on track. Looking at Node, JavaScript, and I thought, look, a better way to see how Node works is to just look at Node, and you can actually build Node. It's really surprisingly easy. So you check out Node, you go to GitHub and you get Node, and it's pretty easy to build. It's in the README, you just run, configure, and make, and you can then just develop it. You can just run it in VS Code and set breakpoints and log stuff and see how everything works, which is surprisingly easy. And you'll see a default threads 4, which is interesting in this thread pool.c. This is Jamie doing some research for me, and he's like, yes, actually there are threads, there's 4 threads, exactly 4 threads. And the reason there are 4 threads is because it's a lot of Node works in the way that the .NET thing I was talking about, where the OS has an async API that just calls back into your code, but Node runs on multiple operating systems, and not every API is async, and there's a whole bunch of synchronous APIs that you have to block on. And then some OSs have synchronous versions, but some operating systems don't have async APIs for some operations. So Node has a thread pool with exactly 4 threads in it for those operations. So when you do one of those operations, you end up scheduled on this thread pool thread that will walk. And this talk kind of started trying to work out how async await worked, but it kind of just went where it went, what we discovered. So Node spun out of this desire to run JavaScript on the server, and the engine for Node is the V8 JavaScript engine, so it's just pulled straight out of Chrome. And one interesting thing we discovered is V8 doesn't actually have an event loop, and it doesn't do any I/O, so it doesn't do network I/O, it doesn't do sockets or files or any sort of stuff. That's all up to the application hosting V8. So it's up to Chrome or it's up to Node. And in the Node case, the library that hosts V8 is called libuv, and that's the thing that runs your event loop and provides all those bindings to the operating system. And interestingly, libuv, tying back to .NET, was actually used for .NET 5's web server, use libuv, which is pretty cool. There's a whole bunch of projects now that use libuv. And the point of libuv is because Node is fully async, libuv provides an async API to Node for everything. And if it's synchronous on a particular operating system, it will queue it work. But as far as Node is concerned, everything is async. So libuv is kind of the thing I'm honing in on in this talk. This is a block diagram from their website of the parts of libuv. So you've got all these a bunch of async things up here, like sockets. The majority of file I/O in Node is actually scheduled in worker threads on the thread pool. DNS, interestingly, is scheduled on the thread pool. Depending on what operating system you're using, these are the mechanisms that are used to tell Node that there's data ready. So when you do a read file on, you do a read to a socket, and you're on Windows, you'll have this I/O completion block, IOCP, which that's the Windows mechanism of notifying a process that there's new data on the socket. On a Mac, it's KQ. On Linux, it's equal. I have no idea what event ports are. Another thing we discovered is it's really easy to starve a Node thread pool with DNS requests, because DNS requests are scheduled on that four worker thread pool. If you've got a slow DNS server and you've got a Node service making tons of DNS requests, you can actually starve that thread pool really easy, and everything else will queue up and just basically lock up. Then we started to look at the event loop. This is the block diagram of the event loop. I'll get into a bit more detail later, but one of the cool things about JavaScript is you just don't have to work when you're writing synchronous code. You're just writing JavaScript code. You don't have to worry about another thread coming along and running while you're running and changing some of your data. So you can freely just assume that you're writing to this local variable, function variable that's not going to be, no one else can enter this function at the same time. And that works via this event loop. So how it works is Node or your browser will run the current function and all the calling functions, right? So there's an entry point into JavaScript, whether it's like if you're in the browser, it might be a DOM event. If you're in Node, it might be a timer, or you're running a script from the command line, and it will run your code until it's completed before it gets back to the event loop to run something else, which is kind of cool. And it can get a bit confusing when you're looking at async await, because you look at this and you think, how can Node run this right to completion and then go back to the event loop? It's doing a lot of stuff. You can't actually add two buffers like that together. I just added it. Might work, but probably I doubt that works. But one other thing we discovered is, like, from Node's point of view, this and this are exactly the same thing. So the async await is just this syntactic sugar around like promises and callbacks. Maybe generators, I don't know exactly how it works in V8, but from Node's point of view, when you're looking at the stacks, like when you're debugging it, like this code does exactly the same thing as this code. And I feel like this is heaps easier to conceptualize how Node will run code right to the end, because you can see you enter main and it returns a promise, and then you're back in the event loop. And then you've got a job to call this, this callback that then reads a file, which puts a job on the event, on the queue. It's all these callbacks, but each point needs between function A, B, and C, you have spinning this event loop. So how do you find the event loop in Node? Well, this was just a bit of fun. Is like, how do you actually find your way around this foreign code base? I thought a good idea would be to just put some find where we write to the console, set a breakpoint, and then write some code that does that. So I've got here, I've got a timer that writes hello Siligong after 5 seconds. And then I went into Node. I did this on Windows because it was really easy to find the Windows API call to write to the console. Write console W, set a breakpoint there. On Linux, it's a bit harder because it's like stream write, and like there's a million stream writes, so this was a bit easier. And then you can just set a breakpoint, run that code, and wait till it hits, and you can see this huge stack. And it was like, 60 frames deep. It was really big. Ended in write, and at the top you can see here we've got run and run timers. And run happens to be the event loop, which is this method here. And not so surprising, it looks very similar to that block diagram earlier down to the method names. So you can kind of really easily look through each method and step. It's actually not that hard to follow. You can just kind of jump into each of those methods and see what it does. Another thing we discovered is, like, we've got this bug here with, we've got this asynchronous, we've got this task to assign support requests to people at Easy Agile, and it's like this node service that runs. And you think of it as synchronous because it's got this, like it's a single method with this async await, and we're doing, as part of the round robin, in the process, we're making HTTP requests, which means we're the rest of the, if it was written like this, it would be very clear that this stuff later is happening on a callback after this web request. Because it's written in this async await method, you kind of think that you're a single process, but that means that you can easily have multiple. I'll explain this very well. You have multiple calls can enter a function. And every time you've got an await, you're really going back on the event loop. So sometimes you do actually have to think about.
So by the time you've read buffer 2, buffer 1 may have changed. Is that what you're doing?
Yeah, basically just like that. Yeah, and it's kind of a bit surprising when used in JavaScript. So another thing so there's this task and a job queue. It's like got so many names, and I've probably got it wrong, because like it's so confusing, but there's like this task queue and no job, sometimes called a job queue, sometimes a macro task queue. And that's for the things like the thing, it's like everything except promise callbacks. So like timers, you've got to read on a socket and then you've got a callback after that. They go into this macro task queue. And that's the list of callbacks that Node has to run on the next run of the event loop. And then you've got these V8 micro tasks, and these are a separate queue, which are for all the things that run after a promise is resolved. And this was really interesting, setting breakpoints, looking at this stuff. So both of those examples there with the promise then and the async await had the same stack. They look the same as far as Node is concerned. But interestingly, like the log statement was happening in the same stack with the timer. So when you've got this event loop over here, like after each, if you've got like a thing running after run queue timers, all the promise continuations are this micro task queue that runs after that step. So this step will be the timers, and then you've got any bans or awaits after a timer, they run immediately after that. If you've got something awaiting a socket, and then you've got awaits after that, they run immediately after the data comes in on the socket. They're not on like another loop of the event. Tasks. It was cool even to see with like a web request that the log was happening. There was stuff in the stack about still decoding. It was like reading the socket and doing the TLS and then writing my log statement. So it was literally like in the same whole stack as reading that last bit of data off the socket, which was kind of cool. We had a look at all the different stuff that can put stuff into these queues in Node to make them run on the event loop. So process.nextTick is an interesting one. That's explicit. It's a Node specific API, and that's to run stuff immediately after It's to run it immediately after the current like block in the event queue. And you might think, why would you want to do that rather than run it on the next iteration? And it'd be rare to do it, but they've got a really good example in the node docs, which is this listening on a socket. So what can happen is you've got this callback here that runs on the listening event. If you were to do like set immediate or set timeout 0 or something like that to schedule this on the next run of the event loop, what can happen is this actually starts listening on the socket immediately, and as you go through the event loop, connections can come in on that socket, and you miss them because you really have to do it before you get to the next block in that event loop. And it's kind of like a special case. These are all the things that throw stuff on the event queue. So next tick is that one that I just talked about before moving on to the next stage of the loop. Promise continuations are next on that, and they're actually in V8, they're not in node. So it's like as V8 leaves a step, it runs through all of its continuations. Then you've got set immediate runs at the bottom of the event loop before any timers, and then right at the top of the loop, it'll run any timeouts or timers that have expired. So I've got this little example here that everyone can have a look at for 30 seconds and try and work out what it's going to print, given I've told you when all of these things run. 30 seconds to have to think about it.
This is harder than I originally.
He was giving me shit earlier, so I was going to change it to a shit stuff, but I that was a lot of work. So just working through it quickly. So, the first thing up, so the set timeout is going to run, like it's going to put a job to do this onto the event queue to run in a second. Now it's going to spin for a while. After a second, we're going to come in here and schedule all of these jobs. Immediately after scheduling the jobs, immediately after this function here returns, we're going to run the things out of that block. So we're still going to be in run timer, but we're going to run next tick, unguard, and promise the continuations in that order. So unguard is up. And we're going to continue down the block diagram of the event loop, and when we get to the bottom, we're going to run set immediate. And then we're going to come back to the next iteration of the event loop and run the timers. And we've got 2 timers here on 0 milliseconds. So they're going to run in order that they were added.
Just a question on that.
Yes.
Dot next tick is number 1. There was a continuation, like there was a level up after dot next tick run. So before resolve.then is run, there was a method you could call to run before that, right? If you go back to
that was process.net.
Go to the next one. Promise continuations. Is that .then?
Yeah.
Okay.
That's .then. But I've since read that maybe like the next tick and the promise continuations might not be well defined. Like it might be an arbitrary law. So that might not be strictly true. The end. Thank you. Woo! Feel free to have some drinks, bio break. Back in 5.
Johnny,
What does UV stand for?
when I was looking around, I was like, I'm not sure if I should be challenging them. So, please no. I don't actually know. Before the talk, I was like telling people about the talk, and Thomas it's generated. So it's from what I can see in the stack, like when I did code, I got the same exact code. You can tell whether something's a variable function.
Yeah.
Dave Hill. Dave Hill, so we'll be talking about BDD and I'll let the discussion, sir. Please make it welcome.
Thank you. Does anyone know how to set up the notes?
Notes.
Or the notes for the. What did I need? That's right. I came up with a plan B, so I will have my phone if I need it. So thank you everyone for having me. My name's Dave Hill. I'm from SmartBear software. Some of you might know us. We're the company behind Soap UI, Success Complete, Zephyr, Cucumber, and a whole. We have about 16 different products that most of you may have been familiar with. But today, I stupidly put my hand up to talk about BDD, which is probably one of the most difficult conversations to have or topics to talk about. Even internally, we talk about SmartBear, how hard it is to get out what BDD really is. There's a pretty big misconception of what BDD is, and a lot of it is taking bits out of BDD. But it really is a full sort of practice of Agile practice. So I'll go into exactly what it is. So just a little bit about SmartBear. If you don't know us at all, we're based in the US. I work from an office down here remotely. I worked in an international office. I am in sales, so I didn't have a clue what Joe was talking about, except for maybe one thing. But yeah, that was an interesting topic to listen to. But I have worked for the last 4 years for SmartBear across all of our tools. So my job is really working with our bigger customers to help them with their problems that they're having and put our solutions in if it does fit, which involves really knowing our tools and the problems they have. And a lot of those conversations are around BDD in some cases as well. So I put a joke just to see. So, has anyone seen this before? Pretty much explains why BDD exists and why TDD exists and why there are other practices that exist. And it explains the communication issue that a lot of us have through projects. It explains where assumptions go wrong. Like for me today, I was late. I assumed is the Agile still in the old office, and then I had to power walk up the hill to get here, which wasn't fun. And that's what happens in a lot of these projects, where a lot of assumptions happen, a lot of miscommunication. And as Eric Evans, if anyone knows Eric Evans, who wrote the design-driven development book, project faces serious problems when its language is fractured. So if you ask Wikipedia, and this is where it comes to how to define BDD, Wikipedia says BDD is an agile software development process that encourages collaboration among developers, QA, and non-technical participants in a software project. It encourages teams to use conversation and concrete examples to formalize an understanding of how the application should behave. So for me, that sort of touches on some stuff. Does anyone know what BDD is here? Is anyone familiar with this BDD? A little bit, yeah, or a lot, maybe. So that kind of does touch on it. It's hard to put that into one summary, but it depends who you're talking to. I try to put it in a different way. BDD is an agile way of working that consists of 3 core practices: discovery, formulation, and automation. And together, they promise to reduce the cost of software development by increasing the value, speed, and quality of the features being delivered. So just look at that again. That's reduce the costs and increase the value, speed, and quality. You can tell the salesperson wrote that because that sounds pretty good to me and to the people that I've shown anyway. But let's just go into the 3 core practices. Discovery, and this again is stuff taken off our own Cucumber website and things, a sort of common summary of each of these core practices. So for discovery, to create a shared understanding of the requirements through collaboration, typically achieved through conversation. Formulation, examples of system behavior documented by using business terminology. A lot of you know that as Gherkin. And then automation, documentation is automated. For me, and for a lot of people that I show that to who don't really know what BDD is, sort of, they can understand the words, but it doesn't really have any meaning. So I try to go one step further and explain exactly what that is, maybe from the perspective of the people who are involved in going through a BDD process. So in discovery, discovery is really a meeting between a business analyst or a product owner, the developers, and testers. Anyone do discoveries? Anyone actually do BDD? Do you practice BDD? Yeah. So just correct me if I'm wrong. Yeah. So discovery is a meeting between technical and the non-technical, and the purpose is, in the summary of what we would see on the internet, is to come to a common understanding. But it's actually more than that. What it is a place where a product owner will bring user stories and acceptance criteria, or what we call rules, or what's called rules in BDD. And it's where a structured conversation is had between the developers and the testers and the product owners to sort of interrogate or to cross-examine these acceptance criteria or rules that to really make sure that they understand, and they do that by giving examples. So from a product owner or an analyst perspective, they come in, they put everything on the table, and then questions get asked. From a developer and a QA perspective, they hear these rules, they hear these user stories, and then they give examples of how they think it might work. And that takes the assumptions, just like me running late. I assumed I was down there, but it wasn't. And just like in a real life situation, I'll run through one, not a real life, but a real life example of how that might work and how that achieves. So at the end of it, you're really building out better rules, better user stories, sometimes splitting user stories out into multiple user stories and multiple rules, things that haven't been thought of. And we call them the known knowns and the known unknowns, and the unknown unknowns. They're the ones that you really thought as an analyst or as a business team, this is exactly what we need. And then the QA might come in and say, actually, my experience, I'm using my experience and expertise. What about this, this, and this? Is this how it works? And then they form these examples. You would see questions in there as well that will come up. Questions usually come up to be taken back if they're not answered, taken back, and they might turn back into user stories as well. But that's part of it. So just giving this example, reserving a book at the library, if anyone goes to the library anymore. But it's a pretty common example people can relate to. So at the library, it's free to take out books that are on the shelves, but there is a charge of $1 if you want to reserve an item that's currently out of loan. So we look at the user story, which is apply reservation charges to library members. And then the acceptance criteria, the rule is members pay a reservation charge of $1. So the conversation goes very simply. As an example, all right, let's say Andrew reserves a book, he's charged $1, and the product owner or the BA might say, absolutely, perfect. And then someone else might say, okay, Andrew reserves 2 books and he's charged $1. And the business analyst might say, that's actually not how it's supposed to work. We didn't think about that now, but that's not how we want it to work. They're going to get charged $2. So they're changing these examples as they go along to relate to the requirements that are there or the rules that are there. And then they say, okay, look, that rule is now changed to per item, and we've got some examples of how that works. Maybe there's a question, is there a limit to number of books to be reserved? PO goes, I haven't really thought of that yet, we're not there yet. I'm going to take that away, we're going to work on that, and then we'll bring that back to the next, bring your answer back, or we'll bring that back to the next meeting. So you can see from this sort of discovery session, this mapping session where they go through using examples, where everybody leaves the meeting having a full understanding using examples of how it's going to work, what they need to do, and there's very little rework that needs to get done because no one's asking questions later on. Everyone's got a full understanding after a successful discovery session. So the next part of BDD is formulation, and formulation is when typically done in pairs by a developer or a tester, or sometimes by one person, where they take those examples and they turn them into business readable specifications. And this is where Gherkin comes in. Most people will say, yeah, I know BDD, Gherkin. And that is one part of it. And that is definitely some very good business use if that's used on its own, absolutely, because you're sort of using that method to understand and give an understanding across all the business what you're doing. But if you're leaving the discovery step out, it's not really BDD because the discovery really helps you build better software by understanding what's happening and working out what's happening. So in this example, given Andrew is a member, when he reserves, etc., then, so given when then, the Gherkin syntax is typically used. And then you'll get something like this where the feature file is being developed. So from here, typically what would happen is the feature files will be written by a pair or one, and then it gives an opportunity for the business side to validate this is exactly what we're going to do. So the next stage is we're going to start development. So we're 100%, we're all on the same page, we're doing this, but this feature file has more uses than just a design specification and a validation that everyone's doing the same thing. It also can be used as system documentation. So put through the right tool, it becomes a living, breathing system documentation for this particular piece of work that's being developed. If this gets updated, so does documentation. So there's an investment up front of doing this to help build out system documentation as you're going along. So the third stage, the core stage within BDD, is automation. And this is the fun part. This is where I suppose anyone who's in development who's using BDD or practicing BDD, this is where they get their hands dirty. But in this stage, really, automation is pretty much TDD. And I'm sure everyone's familiar with TDD, where literally is TDD. You're taking this design spec, you're writing tests for each step within this feature file, and then you're making this particular feature file run through a tool like Cucumber or SpecFlow, whatever you're using to run, and it'll then call that test, fail the test, then you start building your code to make that test pass, which really forces, in true TDD form, forces the developer to think about what code they want to have, they wish they should have, and it helps build sort of better testable code as well in experience that I've talked to people as well. So this is where tools like Cucumber will come in. We can start automating this, where you're running it through, and you can see from in your IDE what's failing, what's passing, and using other tools, there's reporting tools, and then there's pay tools where the business team can actually see this same format, what's passed, what's failed, and they can see the progress of what's happening. So not only is it design specification, it's there for validation through the whole process as well, and progress. So this is going way quicker than I thought it would, which is good because we can open up to questions. What is BDD? It's encouraging collaboration across roles to build a shared understanding and build more valuable software. This is software going back to the first image where what the customer said they want, what they really wanted, and everything in between. And that's what part of this process does. Building system documentation that's automatically checked against the system behavior. So again, building documentation, you're using that to run your tests, or it's living, breathing documentation that's part of the system documentation now and into the future. So if something changes in 4 years' time, someone's going to be able to use this documentation to see what happens. Working in rapid, small iterations to increase feedback and flow of value. And feedback, collaboration, that's a real big key part to BDD. I don't know if that came across easy, but that was really hard to get across. But that's pretty much it. So is there any questions? Does anyone have any questions about BDD, or anyone who practices BDD who wants to go that? Was it right?
We do kind of a discovery. We kind of do a not quite that middle step, and we do the end stuff where we've got open specs, use code sets, run that, all of those things. What we don't really do well, we've found is go from what we determine to be our user requirement, and then what's easy to say the user reserves one book turns into this much steps to actually, we need to create a user, we need to create a library, we need to build an entire environment around it, and then they can reserve a book. So what we find is that kind of we get stuck in that middle step, just to do that one line where the user reserves a book ends up costing us so much effort to make a testable thing because we need an environment around all of that.
Yeah,
that's probably the thing that we struggle with.
Yeah, absolutely, and that's where Cucumber Limited is sort of one of the offsets of, like, we don't do services or anything, but that's their core practice where that is a big thing they coach on, because it's not as easy as going, hey, let's just do BDD and start doing it. Those sort of things come up, and then there's sort of rules you put in place around if the discovery session examples and rules are getting too big, it needs to be broken up, and then there's things that need to happen, and sort of guidelines on how it should be done. And typically, it's sort of hard who owns that. Everyone should sort of own that, but there are guidelines and rules that sort of help with that. But to a point, there is a way that the more you do it, the more you practice BDD, the easier that becomes, and the more fluent it becomes. And you just know, okay, this is getting too big. This goes into this process where we start doing that. But yeah, there's like our guys, they're all in the UK, do all their training and all that, heaps of webinars around how to solve those sort of problems. So yeah, that's good.
I think there's like maybe a lighter version of that to use small startups or early stage startups, because it's great, but the feature out there tomorrow, and there's a big chance that that feature will be told that tomorrow.
Yeah, absolutely.
Hack it in.
Yeah.
Good.
Maybe TDD, maybe.
Well,
No, just straight into production. Yeah.
you know, I actually started a book also
Yeah.
started just how it actually move on that.
Yeah.
It's kind of
It's one of those things you need to weigh up. Do you put?
trade off.
Yeah.
Right? What you're talking
Exactly.
about is great.
Yeah.
And you said if we're going to look at it in 4 years, I really hope that in 4 years, because yesterday startup, and we saw change.
Yeah, absolutely.
Speed is the key.
Yeah.
But there are a lot of things built some principles.
Yeah, well, there's a lot of variations as well. Like you have bigger teams that have a lot of like a test strategy already, and BDD is part of that test strategy, but there's other testing going on outside of that BDD. So while when they're doing BDD and they're writing those feature files and they become a pretty core component of almost regression testing or testing those features, there's still other testing. So in that version where you have a startup, who invests in a test automation team, or it's you need to make sure quality is coming through as well, where that BDD process is baking in quality as well.
Right now, the testing, the most risk is where test.
Yeah.
Because the number of coverage is not involved.
Yeah. Yep. Absolutely. Yeah. I mean, that is a challenge from that perspective. Absolutely. And like Joe said, I want to be convinced of BDD, or I'm looking forward to it. It's good in certain areas, and it's not for everybody, but it can work, and when it works, it can work really, really well. Did you have a question? Sorry.
You go like there'll be a inflection point. Feel like the easy agile classes, like where we wanted to, like we've been very focused on, like on the three of this, like we've got to get this product out. In production, we wrote tests, but like at some point you grow enough that it's like that's a debt you have to then pay down. Yep. You know, like you've got shitty coverage and you've got to take the time out. You bigger if you want to keep growing to get better.
It's quite simple. The number of tests is relative to the amount of revenue. Revenue tests. No revenue, no tests.
And the opportunity cost of breaking something in production factors in there as well. As you get bigger, you have more customers, there's going to be a bigger consequence if something breaks. You need to invest more in the testing at that point as well. Right?
And then the other thing is the discovery portion of this is, well, that's pretty important. That can be done easily. It's just a different conversation to have. Whereas, this is what I want to deliver, but is it really what should be delivered right now, or is it the exact version of what you're thinking based on people's experience and whatnot as well? So where that true value comes from, whether you do the second and third stage or not, that's pretty valuable. And in fact, like the guys who have come up with Cucumber and all that core discovery, the gateway drug to BDD, because once people start doing it, it becomes very obvious how valuable it is.
So I'm a big BDD skeptic.
Yeah.
But now
this was a trap. You invited me to talk.
I watched the talk was great, and I'm like, if that's BDD, I'm like actually into 2/3 of BDD, and I'm a Gherkin skeptic into that. Because I'm really into this, like the discovery sounds really good, and BDD sounds really good. The thing I always feel is a bit silly is the Gherkin and like writing in silly language. And do you have, like, in practice, I get you sit down with the product owner and write out your spec files, and you go and try and write the tests, and really the spec files are wrong. But like 50 units. And you get it running and whatever. Does anybody, like this living system documentation, does anybody ever read that? It's not. It feels like just tests. Whether you be forced to write in a silly language that only then you're going to read, and you just have to learn to pass the silly language. Did like product owners ever go and read this?
Yeah, well, so there's tools where you can, like from a Gherkin point of view, that take the feature file and then put it in a platform that is accessible and easy to read. So like we have a tool called Cucumber Studio where the product owner they'll be imported and syncing between the repository and between Cucumber Studio, and they'll be able to see what's happening. You can actually run tests from there as well. You don't need to be a developer in your own IDE with your own tests doing it. You can actually run tests. So there's tools that will help automate that, even from a CI/CD point of view as well. You can run those feature files, and they will run the tests for you. And then add a benefit of having it business readable and readable to everybody to say this is a common understanding of what's happening and what's actually being built. But yeah, there is a stage where maybe there isn't anyone who's going, well, I have an interest in that, who isn't technical, and then, so.
I say that, but product managers do say, I have no idea what's being tested. So, it's a problem.
Yeah. And that, yeah.
can see the benefit there. You could like even Slack message the test. It was like, and we were checking out a book and it cost $1, so it's really like that's a bad thing.
Yeah.
Which is cool to make it human readable. So everyone understands. But the question I have, which is technical, is how does you reckon know that the text means that it's produced one substitute? Like, is there hints in there to make it realize?
Yeah, so that's you writing it as a developer, you're writing a test like in TDD. So you will look at the feature file and the scenario and you take the step that's there and you write a test for that step before any code is written at all. And then Cucumber will map that step to that test.
Just make the whole one red if it's.
Yeah, and so when you're running that feature file as a test, it'll then go, okay, here's the actual test, running the test. And let's say once you've deployed, you've actually run it against real code, and then it's testing that. So you can run all your feature files, and it'll run all the tests you've written in that TDD sort of scenario.
But if you change the feature file, does that change the requirements of the test?
If you change the feature file, the test will fail.
Then how does it charge what's in that feature file?
Right range expressions.
So it's the name, so it's at given, and then it's it would be the name of the scenario, and then the test that you're writing will be that given, and then it'll be the name, the exact name of that scenario. So there's reuse built in there where you're using the same step where the test is already written for that. So you don't, as a developer, you don't need to write a line of test for every single step in that scenario because it's already mapped to that particular test. So if something changes, then it'll fail. You need to go and change the test, change the code, and then pass.
So, obviously, Derek down, one of the two big problems in my experience, I think, is one to here and yes. One, yes, those tests are given readable, but they're only really programmable because the product owner is not going to know what the rejects matches against, and they're not going to remember that language they have to use to write a regex matchable description. And the second thing is the programmer, in addition to writing tests, ends up also maintaining regex for you. To ensure that the given readable description of the test is executable. So I'm a big fan of testing, but I think that's just the one link in the change the circle is the link to just it's just not great in my experience.
Yeah. So where's regex coming into it in your
well, because you need to have something you can take that human readable description of what the thing is and say, okay, this is the TDD test.
That's what Cucumber does it for you. Maps it all for you.
If it's written in different ways.
It takes a feature file, so giving with that, and you put and Cucumber will read that and go, I can't find a test that's associated with this given step. And then you go and write the test, and then you write the test, and then you map that to the test. So then you go, okay, here's the test. So every time I run this feature file now, I know that test was run.
Yeah, the trouble is, what we want to do is we don't want to write 17,000 tests because I want to click the button that says submit, the button that says send a message, the button that says whatever. So we end up with a regex that says, I click on the button with quote text, and then we end up writing regex that takes the text out of that statement, runs it in a step and passes it out and uses it as a parameter in the query selector that goes and finds the right button to press to run that step. And so that's when we end up with regex. And then someone said change that they use single quotes instead of double quotes, and that breaks the regex. Or the button instead of a button, and that breaks the regex. And
so there's a level where do you do feature files for everything, or do you go, it's just for the functionality of what's supposed to happen? Are you worried about
we have unit test coverage of everything. We have feature tests over our critical part, make sure we can create users, sign up for jobs, create a job. Yeah, that's what key pieces.
Yeah, and you want to have really good communication with the product owner or the worst documented, but that documentation can't be executable.
Yeah. So by the sounds of it, it's not so much that the documentation is executable, but it's mapped to what is executable.
Yeah.
Yeah.
So what we use internally for our unit testing is jest, and with each test there's a description, like describe test name, function name, when you know, a plain text description, it does this, then a plain text description, it does that. And like that is a direct map to what those tests are. I've actually sent one of those files to one of our product managers and said, just read the strings. Is this behavior what we're doing? That seems adjacent to behavior driven.
That's exactly right. And that is that is exactly it. But then you put a feature file on top of that is used as system documentation, and also can be used in other reports and other ways throughout the sort of software project as well. Yeah, exactly right. Yeah.
Our product owner used to write very good stories and write community tests all day pretty well, but maybe it's a question for Dave. Is there anything that works or anything for SmartBear or Easy Agile that's going to bridge the gap between what the product owner wants and what developers try against?
Yep, BDD.
As in like Jira, like the product owner write Jira stories that we test that we
Yeah, absolutely. So Cucumber Studio, which is built on Cucumber itself, well, it's completely different because it's more of a test management or a management sort of tool where you can write your stories in there, set your rules in there, exactly like the map with the notes that are there, just like that. So the same story, rule, example, they're all in the one system. And then that just gets pushed to your source control, and then you can go from there and start filling it all.
There's the idea that generally the product owner and engineering will have these.
That's right. So the story and the rules come in from the product owner, and then this is where discovery really helps, is because you start challenging those rules and that user story with your knowledge and your understanding and your assumptions that you took in to what you're going to do after, so you don't have to go back 2 days or a day and go, hey, what about this? Or I only thought about this now, where that's put out, that feedback is earlier on in the stage of discovery.
Yeah, totally. Like besides the negotiation, like an easy restart, like the ship's from product owner doesn't impact that. I just wonder if there's a way that, I'm not being lazy, but as an engineer, probably just interpret, negotiate, discuss, understand, and then just write functional code. Because it is a bit more like to some extent. Yeah, the product owner's already read some of it, use natural language, and then we're just going to go copy that a little bit, or you could just go at that point.
Yep. Completely lazy.
Let me know.
No,
I understand the customer. Like if you write like basically integration tests in natural language, so you're going to so and so meant to exercise this thing. Like this keywords, and you can exercise like APIs and it reads like a normal story. So you're like integration tests read like stories so that a non-technical person can write them and then execute them.
So, and that also just take away in the BDD world, again, it's not for everybody, where you're writing a test first, like you're actually thinking about how to make that test pass when you're writing your code as well, which changes a little bit the way you're doing it. Obviously, it's not fast. Yeah. But it is sort of making inequality in code as well.
The idea that it's a structured conversation, as you said. I think that's where this tool's going to go so far, but conversations are really, really important. Give a structure to try and draw out those problems early, the unknown unknowns, early as possible. That's the most.
Yeah, so I think which was the most important part.
Yeah. We did a poll, and it was like 56% of the people came back saying that the requirement, from a BA's perspective, the requirements are misunderstood. And that discovery just fixes that.
You see the video with the guy drawing to the back?
Yeah.
And it draws like, it's supposed to be a high screen, it draws the poop.
Yeah.
Emoji, it's kind of like,
that's it. And I reckon that's just human nature. Everyone does it. People have assumptions and, that maybe don't ask questions. But yeah, that discovery is, that QR code there, that link goes to an article that really goes into more depth about discovery. Put that in there because it's probably one of the key pieces here that you can easily take away and do. You don't have to worry about Gherkin, you don't have to worry about Cucumber, you don't have to worry about anything like that. So yeah, there's some good webinars out there as well.
No one's left online, so
Oh, is that bad?
I think it was fantastic. I think that